Good afternoon and welcome. I hope as you're watching this, you're not snowed in, or if you are, you're having a nice indoor day today. The sun's actually shining here in Southampton, but you're very welcome to our latest discussion in our series of asbestos limits a discussion. And this is the third in our FAM webinar series for 2024. At the end of the session, I will give you the heads up on the fourth webinar, which will take place in February. I'll give you some details on that later on. Today, we're looking at a subject that we're all interested in. How can we protect workers better? How can we use our equipment better? And so the title of this webinar is Thinking Outside the Box to Achieve a Valid OEL. Obviously, in the UK, we don't really refer to OEL when we're talking about asbestos, but for our purposes, it would be the control limit. So the purpose of the webinar is to look at how we can adapt the current PCM method, the method that we've had in the UK for over 40 years now. We know and love it. We've invested a lot. If you're a laboratory, you've invested a lot in equipment. And when you look at what's happening in the EU with the lowering of the occupational exposure limit, are we heading that way in the UK? That's what we're interested in discussing. And could we validate the method with PCM? Because there's a lot of discussion in Europe about should there be a shift change over to electron microscopy. And of course, in the UK, we've always had a preference for PCM, something we know and love. But there's also bigger discussions about how do we move on in the industry and try and attract new entrants that are very keen on using apps rather than microscopes. So that is a challenge for the future, and maybe that's the subject of another webinar. So this webinar series has really been prompted by those EU directive changes. If you've read them, the Asbestos Workers Directive, which landed pretty much getting on for a year now, they have to adopt this order of magnitude change to the PCM 8-hour occupational exposure limit by the end of next year. So it's creeping up very fast. Now, obviously, in the UK, we're not intending to go this route. We're watching very carefully, but it has opened up a discussion which FAM is leading to look at where do we really want to be in the UK as the environment changes. So let's introduce our two speakers. Today, as you've seen, Gary is with us again, which is great. Gary heads our FAM SC3 Research Committee, part of FAM, one of the people that really inaugurated FAM back in 2017, and he's been looking at some work on this topic. And once Gary's short presentation of 10 minutes has concluded, we'll have a discussion session, which as Lee mentioned, we use the chat box for answering and reading out your questions. Then it'll be followed by a further short presentation by Martin Harper. Now, if any of you on the webinar today were at the FAM 2023 conference, you would have met Martin there. He was our keynote speaker, and we're very happy to have Martin back with us today. He's based in the US, in Florida, so welcome, Martin, from all those miles away. I'm really pleased that you could join us. And Martin's background, as you will see, is a very eminent academic, has been a proponent of the NIOSH roadmap for asbestos research and the author of the NIOSH Asbestos 7400. So we're very happy to have Martin with us to discuss where we could really go with PCM. So as I say, chat box, if you can use that, we will try and answer all your questions. Please don't be offended if we don't get to your question, but please pose lots of questions and we're aimed to ask them. Okay, well, I'm going to hand over to Gary. And then once I've done that, if I can stop sharing, that would be useful. And then we'll hand over to Gary.
This presentation is about thinking outside the box to achieve a valid OEL. And I'm going to introduce some work we're doing at FAM. So first of all, I'd like to give some thanks. These things don't happen just by themselves. There's a whole list of people who do really important things to make the webinar happen and some of this research happening. So Next, I'd like to talk about where we've come from and where we're going to. The the idea of workplace exposure limits for asbestos have been around quite a long time, but the membrane filter method to monitor them really started in the 60s, and the limits that have been applied, as you can see in the right-hand column, have fallen from 10, 12 fibres per ml to what we consider the EU are asking for in 2029, 0.002. And even in my own memory, I can remember the 2 fibre per ml limit quite easily, if not the 5 fibre per ml limit. So we're looking at 1,000 times reduction in the OEL over about 50 years. So that's to put it in context. What we do at the moment is in the UK is sample 240 litres of air, 1 litre a minute, and onto a 380 millimetre filter, and count 100 Walton Beckett granules, which is about 0.75 or 78 millimetres squared, which is about 1/500th of the filter. If we base the limit of quantification on 20 fibre counts or 40 fibre ends, this gives us a LOQ of 0.04 fibres per ml. That's okay if we're trying to measure 0.1, which is the current control limit. But if Europe are reducing it by a factor of 10, you can see at least we have to reduce, get a 4 times improvement in the LOQ. And really, if it's to keep it the same, a 10 times reduction. And when we start looking at the requirements, EN 482, the European standard for measuring OELs, we really have to get a times 40 improvement. So times 4, times 10, times 40, they're all particularly challenging. Some of the main variables, we can increase the filter loading, higher flow rate plumps, longer sampling times, less filter area exposed. But all these, loading the filter more, require much lower airborne concentrations of asbestos to avoid overloading and sampling bias, which implies there must be much more improved methods of dust suppression in use. We could also reduce the minimum fibre count and improve the precision. Martin Harper is speaking next about this. Or we can count more of the filter area, and this is normally done by counting more fields of view. Compliance, precision of analysis is really set by the Poisson distribution. The best we can achieve is the Poisson distribution, which is shown here. This varies depending on the fibre count, and you can see a factor of 10 is quite easily available for some of the upper and lower confidence limits. We could count more granules to achieve a lower LOQ. At the moment, we count 100 Walton Beckett granules, which means for 20 fibres, worst case situation, 4 out of 5 granules with no fibres, 80%, roughly, you're looking at 80% empty granules. If we increase to 200 or 400, we get to 95%, 380 empty granules. There's big human factor issues there, and clearly a need for image analysis or AI, artificial intelligence. If we look at the Walton Beckett granule, this is the standard granule, and I've got a simple to view diagram here. It's basically 100 microns diameter, has 3 micron divisions on the vertical, 5-micron divisions on the horizontal, and a range of helpful illustrations around it, which were primarily used for doing size distributions, which we don't really do anymore. So there is an argument we don't need those anyway. It'd be interesting to see how many people actually use them. So there are a number of Walton-Beckett graticules. Now, some of the characteristics, they are all 100 micron in diameter. They take up about 14% of the field of view of an optical microscope. They have various fiber aspect ratios and sizes for size distributions. And when this was introduced, they found that it did increase fiber counts, a factor of 1.5 for amosite and 2.5 for chrysotile. But this was done with much more dense samples when we were looking at, exposure limits of 5 fibers per ml or higher. And they also noticed that, the counts were very biased by high numbers of fibers and high particle loadings. So there are a number of biases intrinsically involved. So what BOHS FAM research has been looking on is, can we develop a graticule that is better for low fiber density counting? And the idea was to produce and evaluate a graticule, I'm calling it the BOHS FAM graticule, that is retrocompatible with what has been used before, but can increase the area of the field by a factor of 4. So it takes up about half the field of view. And here's the traditional Walton-Beckett graticule looking down a microscope. As you can see, it doesn't cover an awful lot of the area. And this is the new BOHS FAM graticule. Not the easiest thing to see on the screen, I appreciate, but basically there's an additional circle added, so it's 200 microns diameter, with all the illustrations outside the 200 micron circle. And here's an example you might be able to see a bit better with some actual particles and fibers. What we're trying to do is we've designed it to increase the counting area, and we're working with Graticule Optics Limited, who are helping us to produce the reticles. And we originally had a master and a single reticule produced, which has been initially trialed under the second part of this research project. And there's a bit of a feedback loop. We've been working, it's Louise Slattery has done some counting, and we're finding that there are a couple of improvements in the visibility of the lines. So a new master is being produced and 6 further reticles to go to some volunteer labs who are going to partake in a inter and intra lab training and then design trial. So hopefully these will all be available by mid-December to the labs, and we can start counting in earnest. The initial results we got are factors of 3 now. Ideally, we would expect a ×4 increase. So again, these are initial results, and we'll see how it goes, but it's nothing terrible. We will have those 6 additional reticles available, 7 labs in a trial. They're going to help us out free of charge, so that's collaborative research. And the statistical design is hopefully being done very shortly. And if successful, this will help validate the current HSG 248 method. And hopefully we only need to make minor changes. It will provide a temporary and validated solution to the new EU PCM OEL limit at the end of next year of 0.01. I would stress this isn't a UK limit. Can use as a current Wharton Beckett graticule for high fiber count. So you've still got the 100 micron Wharton Beckett graticule, so you don't have to choose your graticules. You can switch to the larger graticule when you're dealing with low fiber counts. Much less green graticules to view that are empty of fibers, and you can calibrate this quite easily with a stage micrometer. All you do is measure the radius instead of the diameter with the existing stage micrometer. And the most important thing, it will allow us to have valid on-site measurements and rapid feedback in the index of exposure that's been used over the last 50 years. Questions, please. Thank you very much.
So it happened that I started life as a geologist and studied mineralogy under Professor Eric Whitaker, who was a renowned asbestos researcher back in the day. He passed away not too long ago, and I wish I'd been able to tell him that some of it had rubbed off on me and that I was now working on that strange stuff that he kept carrying on about. So we're talking about PCM and why we want to continue using it. It started off that it was a very nice procedure that we could transport out into the environment, into the workplace, and it was very cheap. But the real reason that we kept it is because that it's on the method on which our risk assessment and exposure limits are actually based. So I'm going to talk about determining the risk of exposure, not determining the presence of asbestos. A lot of asbestos measurements these days are done for clearance purposes in abatement. And in that case, you just want to know whether it's present or absent. That should not be confused with an occupational exposure limit where you're determining the risk from exposure. In the USA, all our limits are 0.1 fibers per cc, and currently in the EU, it's generally 0.1 fibers per cubic centimeter, and in each country separately as well, they have their own limits, which are the same, except that a few countries already have a lower limit. And there's this new EU directive to 0.01 fibers per cc. Now, of course, that's in the EU. You might wonder why, anybody in the USA would be interested in that. And it turns out that under the Toxic Substances Control Act, otherwise known as Superfund legislation in the US, the EPA is setting new environmental exposure limits called ECELs. And the ECEL for asbestos, I believe, is 0.0005 fibers per cc, i.e. Half of the new EU directive. So we do need to look at this issue of whether PCM will continue to work at lower levels. OSHA has a permissible exposure limit, and this is the history of that permissible exposure limit. And it ended up that the NIOSH OSHA working group concluded that 0.1 fiber cc should be the exposure limit, as measurements below this using PCM would be considered unreliable at that time. And so this was applied in 1986, and zero 0.1 fibers per cc is not a safe level, and OSHA recognizes that there's still an unacceptable risk of cancer deaths at that limit. But so as a result, it's often considered as a limit of detection. Now, a limit of detection is not a limit value in the European context, as EN 482, European standard, sets expanded uncertainty requirements around the limit value, and limits of detection usually don't have those requirements. Now, OSHA based its PEL on epidemiological evidence from prior exposure response studies and recognized that PCM provides an index of exposure against which the risk assessment was made. And thus, PCM must be used to assess risk when exposures are related to the limit value. Otherwise, if you want to use TEM, you're going to have to do your own risk assessment using the TEM method and set your own limit value according to that risk assessment. As far as I know, that's not been done. So the proposal for the directive from the EU actually recognizes this and states that the exposure risk relationship is based on fiber measurements according to PCM. And they also state that no conversion factors applicable to all situations can convert PCM derived risk estimates to EM based risk estimates. And so this is really important. This is why we have to try to keep PCM for as long as possible. So can the proposed OELV of 0.01 fibers per cc be measured? Well, we need to address a number of issues when attempting to quantify what would inevitably be lower fiber counts. The current methods, all the ones that I've looked at, have the same requirement or similar requirements for a minimum number of fibers per unit area for a countable sample. And actually, this is just not going to be possible at 0.01 fibers per cc. You'll see why in a minute. And so the question is, can this minimum be modified? The lower fiber counts will also require greater precision on the part of microscopists. And the question is, can we confirm that acceptable precision? The lower counts will still require larger samples and or examination of greater areas. Is this possible, or is it going to be cost prohibitive? And these lower counts would be affected by background counts. And so the question is, are filters with consistently low backgrounds available? So let's talk about the minimum fiber density first. Most methods have a minimum of 100 fibers per square millimeter, below which you shouldn't trust the counts. And this is based on a paper that was written by John Cherry in 1986, The Influence of Fiber Density on the Assessment of Fiber Concentration. A deep dive into that paper suggests that this bias at low densities was likely a result of very high background counts that were obtained on filters at that time, interfering with the analysis. And we know that background counts are much lower today. However, to proceed with the method at a 0.01 fibers per cc limit value, we really need to be at 2 fibers per 100 fields or less. I've been on a quest to obtain data from different laboratories using different kinds of filters to assess what the current background levels are. I mean, I don't do the analysis myself, so I can't do it. I'm dependent on the help of others. And so far, what I've seen, I'll give you an example. One company that sells filters, but they don't make them. They buy them from somewhere else. Their plain filters came in with backgrounds up to 6 fibers per 100 fields, which is going to be unacceptable. While the gridded filters came in with no more than 1 fiber per 100 fields. So clearly that company is buying its gridded filters from one organization and its plain filters from another organization. The gridded filters all seem to look okay, but the plain filters may vary. And of course, that's the standard in the US. So we may have to caution people strongly to look at the backgrounds. So what we have to do at the end of the day is change the method and to remove the minimum density restriction and apply a 2 fibers. That should be per 100 fields. Sorry, I thought I corrected that. So 2 fibers per 100 fields maximum background in place of the current 5 or so fibers per 100 fields. Now, how do we assess the proficiency of microscopists? Well, that's typically through a PT program. And I want to describe the Canadian proficiency test program, which is run by Thomas Pang in Ontario, Canada. And he uses reference slides, which are slides with relocatable grids with drawings of the fibers that should be found by any new microscopist looking at them. And that can result in what's called a discrepancy score. And if you participate in that scheme and pass it, Tom has shown that the intra-counter variability of those microscopists is 0.2, while the current method uncertainty bounds are based on an intra-counter variability of 0.45. If we can confirm that 0.2 SR, then we achieve an appropriate level of uncertainty for determining a 95% confidence limit with a fiber count of 20. It's not an LOD anymore. It's actually 95% confidence. Now, this is going to require a change to the methods. We're going to need to require microscopists to participate in, and importantly, to pass the Canadian PT program. And obviously, there's going to be a little additional expense to that. So what would it take to get to 20 fibers? And at a concentration of 0.0053 fibers per cc, that's my calculation of a concentration that you would need to achieve to be 95% certain you're complying with an OELV of 0.01 fibers per cc, given that you've only got a 4-hour sample. Now, based on the typical filter size and typical graphical field, you can do that sampling at 1 liter per minute only if you count 770 graticule fields. Now, if you can use a higher flow rate, and provided you don't overload the filter, for example, at 4 liters per minute, and there are pumps, they're expensive, but they exist, that will sample through a 25 millimeter 0.8 micron MCE filter for 4 hours at least at 4 liters per minute. Then you would only have to count 200 fields. So this would require another change to the method, increasing either or both the pump flow rate and number of fields, or, and this is something that I've also been working on, to try to keep, if you want to try to keep the flow rate the same, you could perhaps move to automation to be able to count many more fields. And I've been working with a company that has a robotic AI microscope, and we're trying to finish up an ASTM standard to use that microscope. So in conclusion, I believe that an OELV of 0.01 fibers per cc can be supported by PCM, and that's important that we can continue to use PCM because it's translatable to the risk assessment. But we have to make some changes to the method. We would have to remove the statement regarding the filter minimum filter coverage required. That wouldn't cost us very much, if anything, just some work on the method. We would have to require more stringent filter background, and there might be a slight cost, especially to people using plain filters. They might have to shop around a bit. We would have to require participation in and passing the Canadian PT program. There's some cost there. The cost would inevitably be, how do you sit out microscopists that don't pass? Unfortunately, we find that most PT programs don't tend to fail people very much, and here it's very possible, especially when beginning the program. People are not normally used to what they see next. We could use higher flow rate pumps. That would cost more, and or count more fields. That would also cost more. We could allow automated counting, but that still needs to be fully validated. And these modifications may increase the cost of sampling and analyses a few fold, but probably not to the differential of EM. And these suggestions that I've made today, I'm putting into a commentary which I'm going to submit for publication, and hopefully we'll see that soon. So that's it. Thank you. I'll be happy to take questions. I'm going to stop sharing now.
Thank you, Martin, for a very succinct but very detailed presentation. It was really useful to hear what's happening in the US. And I think sometimes PCM, because of some of its, maybe because we've always used it in the UK as a QC rather than an absolute limit, in terms of methodology. And sometimes we forget that our whole structure in terms of reducing occupational exposure is based on PCM. And we've had a lot of discussion about electron microscopy, and we've had a couple of workshops, one at, up in HSE in Buxton and one at the University of Brunel, just looking at where it could fit into the UK system. And, we don't have many commercial laboratories that offer that service. And also our clearance process is based on us being mobile, being on site using an analyst to fiber count. So Martin, my question to you, as I'm looking through the chat, please put your questions up there if you've got any to pose. We'd be very happy to talk to you. Is how do we, the psychology of counting, we talked about this a little bit the other day. my analysts in my laboratory, stage 3, which part of our 4-stage clearance. So we do the visual inspection. If we don't find any dust or physical asbestos, then it shouldn't be coming airborne when we do our dust disturbance in stage 3. So when you're rushing around, collecting your samples, you've showered, you've got back to your mobile laboratory, set your microscope up, and then you sit down to count. So already the analyst is thinking, I'm not going to see anything. I'm not going to count anything today, because you're already expecting not to. How do we prevent that happening? Because I do worry that we do maybe miss something, even though we've got QC systems, we've got recounting systems, we have obviously PT schemes. Is there any way, apart from obviously the obvious one would be go to AI, but have you got anything that could help us with that?
Well, there's a lot of questions you just raised there.
Sorry about that.
Okay. So first of all, I just want to reiterate that no one ever believed that PCM could measure every single fiber in the air. It was an index of exposure, and that indexed was placed on the on one axis of the graph against disease on the other to give you the risk assessment, and that gave you the limit value. And therefore the only way you should be addressing a limit value that was derived that way was by using the same methodology that was involved in the derivatization. All right. And the problem is that there's been a race to the bottom. It as once EPA adopted the NIOSH 7400 method for clearance purposes, which it was never designed for in the first place. It was designed as an occupational measurement. But once EPA adopted it for clearance purposes, now we've suddenly got thousands more samples, hundreds of thousands more samples, specifically for that purpose, and a real competition on price to get that big business. And I have a flyer. It's a little dated now, but it's in my drawer from a laboratory that is offering PCM analysis for $5 per sample. Now, I have, if I do it, I have to write reports. I have to, deal with QC requirements. I have to set up my microscope and so on and so forth. I think the only way I could actually make a profit on $5 is by holding the filter up to the light and saying, I don't see any fibers. It's going to cost me more than that just to prep the filter, really. So, this is a problem that, honestly also it's the same problem for electron microscopy too. If all the samples now end up being performed by electron microscopy, you're going to see the same problem. So, I think it's important that we try to monitor the way things are going very carefully. When our accreditation specialists go around laboratories, they actually look at the logs. They look at the numbers of samples that are analyzed each day to make sure that people are not doing 25 an hour, which is not able to be done, particularly since the method itself, the 7400 method, requires so many seconds per field, and so much time in between samples of rest. So that can be audited, which I think it absolutely needs to be. Yeah, did that answer?
Well, sorry, I did pack quite a few questions into that quick one. I think we've definitely got race to the bottom in the UK. We all know that, but it tends to be, we are limited by the number of graticules that we can count, 2,400 in 24-hour period. So we've sort of got that base covered. I think my concern is because asbestos removal techniques have improved such a lot that we're not getting airborne fibres to the rate we did before. So we're nowhere nowhere near the 100 fibres per millimetre squared, to get our precision. So everything, we might just have just very few single digits, which is a problem when you're trying to manage a PT scheme, an internal one. But anyway, I'll stop talking because we have got some questions here. Nick Garland's asking, how far away is the US in terms of developing AI and robotic counting, and what would that actually mean in terms of sort of game change, really?
Well, the system requires to be validated in at least a single user study. Later on, we could also do a multi-lab study. That would be preferred. But we did have the funding from investors to do a single lab study about a year ago. Unfortunately, because of some issues, we did not get the results that we were looking for. And so we now need to come up with the funding to repeat that exercise. And we're looking for about £11,000, if anybody, 15,000 US dollars. If anybody knows anybody that has that money, we can finish off this work. So yeah, it can be finished very quickly, and probably have the actual standard, the ASTM standard, out within a year.
Oh, that'd be excellent. And do you have any idea of how much it would cost?
Yeah,
to
well,
buy
no.
the unit?
No, I do not. I'm not a business person. I don't get involved in that kind of thing.
Very wise.
But what you did ask how much of a game changer it would be. The microscope works by setting itself up using a test slide. So you put a test slide in there, and then you put your sample slides in there. You still have to prepare the slides, okay? The robot is not going to do that for you, okay? But it will, using a macro camera, track a path through the sample that's on the slide, making sure that it avoids uncountable areas like grid lines or overloaded areas. And then it will count the number of fields using stacked images in the Z dimension, and then the AI will be applied to it to determine what's a fiber and what's not. And that process will be a lot faster than a human, and obviously doesn't get tired, and indeed should give you the same result over and over again. And therefore you really don't have and also two microscopes with the same robotics and the same AI should also give you the same results. So you won't have an intra-counter variability to be concerned about anymore. So I think this is a brilliant idea. It's it truly is the applicability of AI in the IH business, and I think it would really help. That's where we are.
So, and the system is Marvin AI, isn't it? Or is it called Marvin?
Yes,
Yeah.
yeah.
So if
The
anyone wants to look
systems,
that up.
right, and the company is now called Marvin Labs.
Right, right.
Now
And they're
they all
based.
they also they also have another microscope which they use for mold spore identification and counting, fungal spore identification and counting, and that is quite successful. Um, of course, that does. What somebody's just asked, how does Marvin fare in the PT scheme? We're actually using slides from that PT scheme to do the validation on Marvin. We have 4 chrysotile slides made from AIHA PT samples, 4 amosite slides made from AIHA PT samples, 4 chrysotile field samples, 4 amosite field samples, and 4 field samples that can from a cement plant that contain both chrysotile and chrysotile. And so those are the slides that we're using to perform the single lab study to validate Marvin.
And just one more question from Martin Saunders, just looking at the blank filter matrix for predominantly our gridded membrane filters that we use in the UK. We've got a quality control standard in HSG 248. Is our market big enough to force their hand? And we had problems with Millipore changing their printing on gridded filters a few years ago, which sent everyone, sort of, it went a little crazy for a while in the UK because we were trying to find a new supplier, having used Millipore for so long. But is the asbestos market too small for them to improve the quality, clean room costs, etc., to improve things for us?
No.
Yeah. I thought there would be a short answer to that one.
As many of you know, I actually worked for 2 instrument vendor companies as the director of research, and I have had conversations with filter manufacturers, and our business is just such a tiny part of their overall business. I mean, don't forget, these guys, sell filters to make filtered beer. How can we compete with that? I mean,
maybe there's a business
we've got
opportunity there.
we've got no chance.
I think really, Martin, thank you so much for your time today and kicking off really an interesting discussion. And I think the US is facing the same problems that the UK are at the moment. Where do we go? Where do we head? And I think AI is something we really need to think about in the UK, but it will have an impact on our workforce, of course. I know I've discussed it with my analysts, and they didn't see what the need for AI was, but it could well be a way of increasing the number of fields so that we can get that lower LEQ. We don't exhaust our analysts, which we know that stage 2 is the most important part, but the clearance process, well, some of you might argue it's not. But if anyone got any questions, I'm just reading very quickly. Yes, the AI scheme, Martin, you might want to come back on here. Again, Martin, thank you for posing this question. Are trained using the Upranol mounting method. Has this changed to acetone triacetone method, which is what we favour in the UK?
The Marvin method was initially validated using acetone triacetone. There are issues with the acetone triacetone method, and it's one of the reasons why I prefer the DMF Uparol. The first issue is that if the acetone is applied too quickly, there's the possibility of flushing fibers off the filter. The use of gridded filters helps with that because it shows up any distortion of the filter itself during that clearance procedure, but you still have to be careful of it. Triacetin, people generally use too much, and as a result, the fibers can float around in the triacetin and move, and they start moving right away. So if you want to maintain your samples over time, you either got to use the absolutely correct amount of triacetin in the method, which nobody ever measures, so hardly anybody ever does, or use Uparol, which will actually fix the fibers in place for sure. The final thing is that there are some MCE filters out there that the acetone triacetin method will produce a texture when it's used on those filters that looks like the kind of craquelure that you get on old pottery. And some of that looks like fiber, and you may end up counting it. And Eric Chatfield in Canada, he gave a presentation on that to one of the ASTM Rook conferences, showing pictures of it, and said, "That's it. I'm only using the DMF Uparol method from now on." Now, having said that, you can use acetone with Uparol, and you can use DMF with triacetin. Any combination is possible. It's just that the typical procedures are acetone, triacetin, or DMF Uparol.
Thank you for that. Matt Stewart has posed a question about overloading of filters. So during compliance testing, and sending it to a laboratory where they do the dilution technique, but apparently it's no longer valid for demonstration of compliance. He's saying, can you speak to whether there is a role for the use of dilution techniques to demonstrate compliance?
I would think that from an occupational exposure point of view, if you're dealing with so much dust that the filter's completely overloaded, then you've got a problem generally with dust exposure, and that maybe if you fix that, you won't have the problem that necessitates dilution. Now, if you're, I can understand that if you're doing an aggressive cleaning during an abatement procedure, that you may produce, a very significant amount of dust. But there's certainly no dilution procedure in the NIOSH 7400 method, and I haven't seen it in any other methods either.
Thank you. And one last question, really, from Nick, was: is Marvin in use, the AI robotic counting? Is that in use in Australia, and have they validated it?
I believe that some were sold in Australia, and I believe they might be in use, in which case NATA, the Australian audit people would have to have okayed it. But I'm not aware of any background data that was used to qualify Marvin in that case, and that's why we're having to do our own single user study here.
It would be good to do the same in the UK. Watch this space. We'll have to raise another £10,000 or so.
Oh yeah. We're very grateful to Tom Pang for lending us the slides. He hasn't even hasn't even charged them for us, and that those things are expensive. So we have to look after them, not break them.
Yeah, yeah, and yeah, maybe there's a case of crowdfunding. Well, I'm afraid we really have lost Gary this time to the deep darkest sort of no power of Cornwall. So I'm really sorry this afternoon for losing out on Gary, but we will have the full presentation that we will come back to when Lee's put it together and put it up onto the website. So thank you very much, Martin. I'm going to finish off now because I'm very aware we're getting towards the end of our session here, and I'm just going to finish off the session with just a couple of slides to round up, really. You'll see on the slide here, really a call out, can you help? We want to look at a little bit of research that Martin and Gary are looking into on media blank filter QC data. So after probably tomorrow or later today, you'll receive an email with a bit of a feedback form, but also a call out with this very simple Excel spreadsheet just saying, could you load up some data and share it with us? So we can just have a look at what's the state of play currently in the UK with media blank filter QC. It's something that hopefully we can help with and send it on to marketing at BOHS. Just want to do a bit of promotion as well as we wrap up here today. It's really an announcement that the FAM conference will be in May next year, the 14th and 15th of May. And this really is a call for papers, talks, posters. We really need your help to fill the conference with science innovation, with practitioners' experiences, just to make it a really, really accessible, good conference that we all get something from. So if you have anything you would like to share with us, please get in touch with conferences@bohs.org. And there's the link there if you want to find out more. It's on the BOHS website. And there is, book early. We're doing a promotion at the moment because we really want as many people as possible to come along. So finally, as we say goodbye, we've got some feedback. You can QR code it now. It does work. I have tested it. And we have our next webinar that will be coming up on the 4th of February. And we're going to look at respiratory protection and the OEL, a discussion on that, because clearly, if the OEL is reduced, how is that going to affect what we associate with assigned protection factors for RPE in the UK for asbestos workers? So that will be the next subject that we're going to tackle in February. So that's all from us. I just want to say thank you very much to Martin and to Gary, and sadly we've lost him, so I can't say goodbye online, but anyway, thank you very much to Martin. Thank you all for coming and sharing this with us this afternoon. Really appreciate your time, and we look forward to seeing you at the next webinar in February. Take care. Thank you for now.